It says, consider a planet at rest and a spaceship that whizzes past the planet at high speed. An observer on the planet sees a contracted spaceship. So we mentioned this in the previous problem that based on an observer at rest, objects moving at a certain velocity are going to be contracted. While an observer on the spaceship sees what? Well, this is similar to the very first question that we started with. We said, according to a person on Earth, a person in the rocket will have a slower time. According to a person on the rocket, what are they going to experience? And we concluded that the person in the rocket will also think that the person on Earth will have a slower time, because you shouldn't be able to tell that you are the one that's actually moving, right? So in this case, what's going to happen? Well, if this is the normal rocket whizzing by a planet like this, right? According to an observer on Earth, right? The rocket will appear what? Contracted, right? So the rocket will look something like this, right? So if the original length of the rocket was something like that, we call that the proper length, then its relativistic length will be shorter. Well, according to a person in the rocket is going to think what? According to the person in the rocket, their rocket is normal. The planet has been squished in the direction parallel to the direction of travel. So the planet will appear something like this, right? The vertical distance will not change. The vertical distance stays the same. The horizontal distance parallel to the direction of travel. So the planet is coming this way, right? So the direction of the planet parallel to the direction of travel has been contracted. And of course, if you're someone standing there, they're also being contracted, right? So it's the same. So therefore, the person in the rocket thinks they're stationary, and the person on the planet thinks they're stationary and the rocket is moving. They can't come to an agreement, right? So what's the answer here? The observer on the spaceship sees a contracted planet. B says an expanded planet. No, it can't be an expanded, because then it would they could determine who is the one moving. C, a normal planet. No, that would mean it's not changed. D, could be contracted or expanded depending on the direction of travel. That can't be. One of the common thought experiments that we use to illustrate this length contraction, it goes like this. We say, imagine there's a person running very fast, let's say close to the speed of light, and they are holding a long ladder. Let's say they're going fast enough, right? And there is a certain house here that has an open door. And then there's another open door here, right? And what we're going to do is we're going to assume that the person is going so fast that the length of the ladder has been contracted. According to a person on Earth, the length is contracted so much so that the person on Earth sees the length of the ladder as being equal to the length of the house, right? So they're going to think that the length of the ladder is something like this. Right? And of course, the person will look contracted too. So the person on Earth decides that once this person running is right in the middle of the house, right? And the ladder is like this, then they set up cameras on the two sides of the house. They set up camera, and then we can call this one the camera 1, and then we can call this one camera 2. And what they do is they have them simultaneously taking a picture, right? They take a picture of the two ends of the house, And so what's going to happen when the two pictures are viewed? Well, if they are simultaneously taken, right, what's going to happen? The person with the ladder should not be seen. The ladder should be completely inside of the house, right? So the picture should be that the ladder does not come out in either picture. So at the end, when this person stops, right, this person takes to them two pictures, neither picture has the ladder. Now, how would the person running explain this? The person running views it completely different, right? The person running sees a big ladder. They think that they are the one that's stationary, right? And the person on Earth has been contracted. And the house has been contracted. Okay, so the house looks like this. Okay, so based on the person that's running, they are stationary and the house is coming towards them, right, with a velocity. How do they explain the fact that when they see the picture, the ladder is not observed? There's no way the complete ladder can fit inside of the house. Okay, the house has been contracted. The ladder is much bigger to begin with. They use the non-simultaneity of the two cameras, right? So there's a camera over here, which we call camera 2, and then camera 1. Based on the person running, which camera should go off first? And I explained this when I did the clock problem, right? Imagine there's a beam of light here going this way, making sure that the two cameras go off at the same time, right? The camera 2 should go off first, right? That would be like the back clock in the previous problem. So what's going to happen is this. The house is going to come here. It looks like this. The camera 2 is going to go first. And it's not going to see the ladder, right? Then, sometime later, the house is going to come all the way here. Right? Then camera 1 is going to go. Camera 1. Now it's going to take a picture. So based on the person running, they say, here is what happened. Your house was also contracted. But camera 2 took the picture first. Then camera 1 took the picture. That is why I was able to fit inside of the house. It's not because the ladder was smaller than the house. The house was actually smaller. But the two cameras did not go off at the same time, you see. So at the end, they have to come to agreement, but their explanations can be different and will be different, okay? So a little bit of a side topic that I wanted to talk about, because it has to do with this concept of linked contraction. They both see each other as contracted, but because of the issue of simultaneity, they might come to the same conclusion at the end, okay? Thank you.